Hey, it's Daryl again. I'm going to try this new style of video where I put myself down in the bottom corner of the screen and have the rest of the screen viewing. I'm just going to say a few things about what I think is interesting weather about New Zealand and what some of the side effects of that are, and compare it to interesting weather that's happening in other places in the world at the moment. But first I'd like to say thanks for the people who subscribed to my channel recently. I had a day where I had like a whole bunch of people all subscribe at once, and I always think it's odd how that happens. You make a video, and it just seems to have something that um, people appreciate, and for whatever reason, you suddenly get a bunch of subscriptions. I'm asking people who like my channel to subscribe. If you're watching my videos, click on subscribe. I'm trying to get up to the magical 1,000 subscribers mark. I think I've got about 300 at the moment. I just think it's fun to try and set goals and get some sort of subscriber base. Again, another thing that happened was a lot of people shared a couple of my videos in the last week or so, and maybe that was what led to subscribers. So anyway, asking for people, if you watch my videos, please subscribe. That would be really awesome. That would help me out a lot. Gives me a lot of encouragement to keep making videos. Okay, enough of that. Anyway, so I'm looking at Null School again. So the website for this webpage, you can look at this on your iPad or phone or computer. It requires a little bit of computing power, but anybody with some kind of modern device should be able to have a look at it, and it should work quite nicely. So the address is earth.nullschool.net. I might put a caption in with that when I edit the video. So I'm looking at New Zealand, and we're looking at, I can't remember what I set it for, so let's just have a look. So if you click on Earth, so I'll just go back here. I'll show you a little marker. So here we go. So here there's this thing that says Earth. Just click on that. You can click on it with your finger if you're on a tablet or some type of device, or just use your mouse otherwise. And then you can choose the different options. And so I'll just quickly go through. So here there's my marker again. Here where there's control, you can click on this now button, and that will give you what the weather is right now, or else you can use these arrows to skip by days or I think 3-hour segments. And you can choose whether you're looking at the air, ocean, chemicals in the air, or sea, or whatever, or particulates. I think it's chemicals in the air. And then you can look at the altitude. So this is about air pressure. So looking at the height of the surface. I like to look at the high altitudes from time to time. So that's like here where there's 10 hectopascals. That's way, way high in the atmosphere. Almost in space, but not quite in space. And to give you a comparison, 250 millibars is the jet streams where international airliners might fly. You can look at these different things. So anyway, we're looking at the wind at the moment. Oh, so we're just looking at how's the wind blowing at the surface in the air. So what we've got is the wind coming in from the east, which is abnormal for New Zealand. We tend to get westerlies, which come in. So normally we just get wind coming in this way, but we've got the exact opposite at the surface at this moment. And because I live in Kapiti, which is right here, I think it's about there, about 50 kilometres north of Wellington. The capital of New Zealand is Wellington, and it's at the bottom of the North Island, just in that there's a little bight there, little harbour. Because the wind is blowing in from the east, which is abnormal, and because New Zealand has a big mountain range, so there's a mountain range that goes all the way through here to the central plateau. So the tip of the arrow is where the central plateau is. Lake Taupo and Mount Ruapehu's there. And so because the wind's coming in over the mountain range, today it's warm and dry. So if we get some temperatures showing on here, let's get temperatures. I can click on a few places, and you click on Earth again to close the menu. So if we click here at Napier, you can see it's about 18 degrees, and where I am at the moment, it's about 20 on land, 23 degrees, somewhere around there. So where I am, it's about 23 degrees. Slow moving breeze. So it's quite warm outside. Everybody's mowing their lawns today. Lawns. I should do a video on lawns. I have something against lawns. And yeah, what I found interesting was when I went to the beach the other day, I went for a swim and the water was super warm. So if we go to, oh yeah, hang on, I wanted to say something about the wind. When the wind goes over the mountain, what happens is you lose the moisture on one side, and then you get the dry air comes down the mountain on the other side, and because it's going down the mountain and the air pressure is higher at ground level, the air compresses as it goes downhill, and it ends up being warmer. This is called Fron wind. I'm never sure how to pronounce this. Fern wind. I should learn how to read IPA, but I almost never do. I clicked on the help here, and I needed to look for this sort of thing that looks like a number 3 in a colon. Maybe it's this. It's this. Is sound as a nurse? Is this hurry, nourish, nurse, word, girl, fern? So if that's the sound I'm looking for, then it's fern wind. Fern wind it is. There we go. And so fern wind is the air that comes down a mountain, and it compresses as it comes down, and it makes for warm, dry winds, which is what the weather feels like today, even though it's not very windy, but it's a slow moving breeze. It makes it feel warm. And you might not think that 23 degrees is very warm, but that's warm for New Zealand. So we use Celsius. If you're from the United States, I'm not sure what this is, maybe around 70 degrees. It's quite warm. If you're outside in the sun, it's actually pretty hot today, even though it's just 23 degrees. And recently we were having high 20s in quite a lot of places around New Zealand. I think we got into the 30s, but that's typical for this time of year in summer. Anyway, yeah, that's a good diagram from Wikipedia. And so I'll go back to here again. So I was at the beach the other day and I noticed that it was really warm. So I'm going to go to the sea surface temperatures. So if I go on ocean and then choose sea surface temperatures and then go on Earth and then click on here, we can get 19.5 degrees in there. Around 20 degrees. I think not long ago it was about 21 degrees. So this is quite warm for the sea temperature. Well, it's not normal because if we stand back, just to give you an example, bottom of the South Island, 15 degrees. Top of the North Island, 22 degrees. So what it's about 500 kilometers from Wellington up to Auckland, so I'm going to say 3 times. 1,500 kilometers north to south, something like that. So we have a interesting climatological variation. So you can see that we are down the south, around the similar latitude as Tasmania or Melbourne, or even if you go right to the north, Sydney's right up parallel with sort of the top of the North Island. But we are normally being exposed to a sea temperature and air temperature that's different than Australia. Australia is so giant, it's got that continental weather systems going on, and we don't have that. We're much more of a island nation, oceanic weather systems kind of a country. And so our weather is cooler and wetter than Australia generally. And then if we look at the sea surface temperature anomaly, SSTA, you can see that the New Zealand's surrounded by abnormally warm water for this time of year. I've made a video on this before, but I do find it's fascinating. I think this is the thing that's controlling, controlling our weather this summer season, which seems to be much warmer than last summer. Last summer was abnormally cold, and this summer seems abnormally warm. And the sea surface temperature anomaly has been like this even from maybe November or definitely in December. So we've been through January and we're 9th of February now. So you can see that we have, if you look at yellow, that means 3.5 degrees warmer than normal. So a lot of the South Island is surrounded by 2.5 to 3.5 degrees warmer than normal, which is, you know, obviously super abnormal. And here where I am in this sort of area, it looks like a kind of a bay, but it's so giant. It's like 100 kilometers or more across, so it's not really a bay. It's very oceanic. There are a lot of little islands actually out here, which most people never know are there. Even when you go to the beach, you don't normally see them, but occasionally you can see these little islands. It was quite surprising for me when I first saw them. I was like, wow, I didn't know there were islands there. Anyway, getting very rambly now. So that's the sea surface temperature anomaly. And so if you have a look at the whole hemisphere, you can see that the hot bits are very, very hot. Here's some cold bits, minus 1.4 degrees, minus 1.8. So there are a few abnormally cool bits, but overall it looks like the abnormally warm bits are warmer than the abnormally cool bits. And to me, there seems to be more red ocean than there does seem to be blue ocean. So you can say that this might mean that on average, the oceans are warmer, and I think this agrees. If you look at maps, you can see that the oceans are generally warmer than they were, say, 20 years ago. And then I thought it would be interesting to look at the air at altitude. So I'll just show you the airflows around New Zealand at surface. So if we go here and we say air, and then we go surface and go wind, you can see that the wind is coming from the east there, and that's at surface. And then if we go to high altitudes, so let's go to the jetstream 250 millibars, this is where aircraft fly, you can see that it's nor'wester of jetstream air from the tropics, so that could be affecting kind of our weather as well. If you're going to fly from, say you're going to fly from Brisbane, which is say up here, if you go straight across here on the plane, then get into this high-speed wind, you can come down to Auckland or Wellington at near supersonic speeds, even in a subsonic jet airliner. I've been on a plane which averaged faster than the speed of sound. At least that's what the pilot said. We were doing an average of the speed of sound across the Tasman, because generally the wind just blows straight across, not diagonally like this. So it's a little unusual, nothing that I can say much about at the moment, the way it's set up. And if you look at this from the pole, you can see that generally the wind blows round and around the pole. The reason why it blows round and around the pole is something to do with the rotation of the Earth and the coldness of Antarctica. So because Antarctica is got a bit of altitude, and a lot of the altitude is covered in a lot of ice, giving slightly more altitude, you end up with the wind blowing round and around this pole of the planet. And in the northern hemisphere, the same is sort of true as well. So you can see that the wind is sort of blowing around, but we have these weird inclusions, strange variations. A lot of scientists have been warning that this is quite problematic, and the reason for that is because air streams that are blowing up and down the planet between north and south are moving cold air much further south than it normally would, and moving warm air much further north than it normally would. And the reason for that fault happening is because as the North Pole and the South Pole, to that matter, warm abnormally, it means that the temperature difference between the equator and the pole isn't as much, and so instead of the air stably going around the medium temperature, forming a kind of an air barrier that blows around and around in a circle, as the temperatures at the poles and the equator become too similar, then these patterns just go very wavy, and that's not good because that makes the air even more flow from the poles to the equator and from the equator to the poles, which even more makes the North Pole or the South Pole warmer and makes the equator, well, not very much cooler, but definitely making the poles warmer. So that's problematic. And if you go to the very high altitudes, you can see these patterns as well. So if we just look at the South Pole, so at the very high altitudes, it's a very circular flow, which is totally awesome, and you can see that flow is going actually at the opposite direction of the jet streams lower down, which is fascinating. Well, maybe it's agreeing with the jet streams actually blowing across up here. Let's just have a look at 250 again. No, I don't know. It's all over the place. Anyway, let's look at this pattern again at the 10 hectopascals. So if you look up at the North Pole, there's this really interesting thing happening. I'll just show you the South Pole again. So you can see the South Pole is a perfectly circular flow, pretty much perfectly circular there. And at the North Pole, it's perfectly oval. And this is problematic because what you're getting is, instead of a peaking of the weather system over the North Pole, which is where it would be really icy, because the North Pole is not cold enough, the weather system is not rotating around the North Pole. If we zoom in, you can see the cross there. It's just in this, where this pink and red line is the center of the cross of the, so here I put the marker on the pole. So at the North Pole there, we've got this oval shaped flow, which is bringing cold air down to the middle of the United States and up to, I'll just show view from the Asia side, over Russia. So this is directly north of India. You can see there's a big flow that comes down, it goes over Siberia and back up. And then we end up with these two sort of nodes of flow there. So that's making the weather, I don't know, I don't know much about the weather in this region. Whatever, it's making it slightly abnormal. Isn't it super cold? Isn't it? I think it's super cold in Korea at the moment because they're about to have the Winter Olympics, and they're worried that it was super cold. And then again there, and isn't it being super cold in England as well? So we've got these weird eddies making everything abnormal, and because the cool air is coming down, that's making these regions super cold as well. So there you can see this this flow, which is bringing weird air streams over Europe. Anyway, that should be circular, it shouldn't be oval. It would be circular if the North Pole was sufficiently cold, but we've got to this point where there's just weird stuff going on with the climate now, and it's to do with just the general average heating of the world. Anyway, I thought that would be interesting. Oh yeah, that's right. I wanted to say one more thing about the beach. I wanted to say about shellfish. So if we go back to, we'll go back to the ocean temperature, sea surface temperature, Earth, there we go. Down here, so I was at the beach the other day, I went for a swim because the water's warmer than it is normally. I think last year I didn't go for a swim at all, the summer was so cold. I did go to the beach a few times. It's hard not to go to the beach when you live in New Zealand because almost everybody lives by the beach or within a few blocks of the beach. It's super common. I think most people in New Zealand live certainly within like about a 20-minute car ride of the beach for the great amounts of the population. So, you know, we're a really coastal kind of a nation with most of our big cities and towns, you know, located near the beach, and so you go to the beach a lot. Anyway, I was looking at these shellfish. We have a few different kinds of shellfish in New Zealand. I can show you the shellfish slideshow. Here we go, the shellfish slideshow. So yeah, these are cockles. You can eat these. I think that they might have some limitation of the number that you can take per day, but I think it's a large number. you just go out when the tide's out a bit and dig in the shallow water, and you can find these shellfish that grow along all the sort of sandy beaches, as far as I know, sort of everywhere in New Zealand, or certainly everywhere in the North Island. And these shells are from tuatua, and tuatua are another sort of smallish shellfish. They're, I don't know, you can eat them maybe when they're 5 to 7, 8 centimeters wide. They look pretty similar to another kind of fish called toaroa, but toaroas always have a closed season. I think there's been 2 open seasons that I remember in my lifetime. And an open season lasted 1 day, and you're allowed to take 5 shellfish. But these tuatuas you can kind of eat any time. These ones are pretty small ones, and they probably wouldn't be any good to eat. The seagulls have been eating these. Here's some more here. This photo looks like it's oddly upside down. They're kind of the size of the ones that you might eat, about 5-7 centimeters across, something like that. And here's a bunch more that are in the sea. And it was kind of interesting because there's actually really tiny ones here. If you see here, there's a tiny one just there. Maybe I can make this image bigger. Yeah, so there's a tiny one just there. Anyway, I saw that there were hundreds of tiny ones, and these other these are kind of like 2-3 centimeters, these ones. This one's less than a centimeter across. There are just a lot of these washed up on the beach, and it looked like it was a kind of like a mass shellfish die-off. I rang up my brother about it, and he said he'd been to the beach himself, in the same week as I went for a swim, and he was talking to a sort of older Maori guy, and he said, oh no, there's just loads and loads of shellfish, way more than he had ever seen in his lifetime. So that's quite fascinating. Lots of families were out with a bucket digging for these shellfish, and they're filling up a bucket really quick. I remember when I was a kid, we had a house by the beach, and we'd pick up these shellfish quite a lot, and you know, you'd have to look around and find a bed of the shellfish on the beach, and then you can go and dig them up. But the chap who'd been there for a while, he said, oh yeah, no, this is just everywhere you dig, there's shellfish. And that's what I noticed. I was building a sandcastle the other day, and I just dug up there were just small ones, like little ones this size and maybe twice as big. They were just everywhere. Everywhere you dug in the sand, there were just shellfish everywhere. So there's something's happened which has caused an abnormally large number of these shellfish to grow. I don't know how fast they grow or how old a 1 centimeter long shellfish or a 3 centimeter long shellfish would be, but I would imagine that the ones that are 3 centimeters long must be maybe a year old or something. I don't know. Does anyone know the answer to that question? And do I have any other interesting shellfish photos? Oh yeah, this photo. Yeah, so here's a lot of these little ones that were just, you know, 1.5 centimeters wide, something like that. So that's these ones here. They look like about 1.5 centimeters wide. But you can see there's, I'm just going to point out, there's all these little marks in the sand. See here, and here, and here, and here. All these little bumps are from little shellfish. So when the wave, so this is just where the waves are. So it's sort of at mid-tide. When a wave washed over the beach, a lot of these little shellfish would wash up out of the sand, and then when the water retreated again, they'd all dig in, and so they've left all these little marks. And so the ones that aren't digging in are kind of dead. And the seagulls seem to be having a good time finding lots of food, which is great for them. But I always worry that when there's weird ecological changes, that means that something odd is happening. Anyway, yeah, that's my story about going to the beach. Yeah, there we go. Back to the map of the world. Anyway, that's my video. yeah, I hope everybody enjoys seeing it. Again, yeah, if you watch my videos a lot, I'd like you to subscribe. That would be really awesome. I noticed that about 20 times more people watch my videos than have subscribed to my videos, which is interesting. So I've got like a reasonable viewership, but not a big number of subscribers. Yeah, thanks again for watching. Share, like, subscribe, and ask questions in the comments. If you ask me any questions, I might be able to answer them for you. Might be able to answer questions if you've got general questions about New Zealand. Pretty good at finding answers for things. And my expertise is in kind of like electronics and electrical stuff, and I have a science background. And yeah, great. Thanks for watching.